Hello everyone. So today in this video we are going to learn about distance and displacement, and let us try to understand about this topic in detail. If demands, we will be solving few problems on this topic. Okay, so now let us consider an example where a person started his journey from a, let me suppose, a place somewhere like Hyderabad or Vijayawada, some any other place you can consider, and say he is about to reach the other place B. Fine. So now, as usual, we already know that to travel between two different points we may have multiple paths. So in any way we can reach from one point to the other point. Similarly, in this case also, the person is having different ways. So let me say this is the first way where he can traverse between A and B. What do you mean by traverse? That is nothing but travel. And now say there is another way where this person can move from A to B in this direction also. And assume there is one more path away where he can go from A to B, and there is another way where he can just move back a little bit and then he just approaches path B, and similarly one more, assume in this way, changing his own directions and all. So finally he reached B passing through different paths, and let us label those paths be some with numbers. Let us say this is path 1, and here we are having this is path 2, and say this is path 3 and 4, and similarly the final one path 5. So now if you just observe one more thing here, in path 1 he is just initially having a particular way, and due course the direction of the particle is continuously changing, and thus in path 2 is also, you can see here, he is undergoing a different ways, and in path 3, and then he is having in this way, you can observe the direction, and in path 4 you can see there is a different ways where he is moving throughout the journey from A to B, like, and in path 5 also you can observe there are different directions he is just crossing through. So taking into account of all these things, I would like to explain the key terms distance and displacement using this way. So see here, first let us understand what is distance. So I would like to say here, so distance, in our daily life we will be using this word distance in many situations, like what is the distance of your house from school, or what is the distance of so and so shop, what's the distance of so and so restaurant from here or from that place. Well, see, many situations are there where we will use this word called distance, but exactly defining what is distance in physics terminology, let us see this one. So distance is nothing but simply, we can understand simply, length. Directly I would like to say length of the path. Okay, I would like to say this is as length of the path traveled between, length of the path traveled between 2 points, between 2 points. Say what are these 2 points? You can say like initial and final points, initial and final points, that too irrespective of direction, irrespective of direction. This is quite important for us here. Okay, is called as distance, simply is called as distance. So what I would like to say about distance is, let us see once again the definition. Length of the path traveled between 2 points, that is initial and final points, irrespective of direction, is called distance. So it means we no need to consider in which direction are you taking a path to travel between A and B. So you are about to reach B when started from A, irrespective of any direction. Let me say you are moving in different ways in a different paths, and the total, I mean like the length of that path taken by you to reach from A to B is called as distance. So in above example, if you see here, in above example, you might have been guessed by the time now itself. So in above example, there are many paths, out of which path 1, 2, 4 and 5. Okay, these paths have, I mean like traveling irrespective of direction. The particle is, or the person is traveling in these paths irrespective of direction, irrespective of direction. So therefore what I could say directly is length of these paths, length, directly length of these above paths we can say straight away as distance between the 2 points A and B. So see here, so path 1, the length of the path 1 is a distance, length of path 2 is also distance, length of path 4 is also distance, length of path 5 is also distance. You can ask me, sir, what about length of path 3? See, length of path 3 is also a distance, but this distance is in a particular direction. So that's why I didn't mention anything about path 3 over here. We will do in the coming example next. Okay, so therefore path 3 you just keep it aside for time being now. So path 1, 2, 4 and 5. So lengths of these paths, length of these paths 1, 2, 4 and 5 is nothing but a distance between 2 points A and B as they were measured irrespective of direction. It means the person is moving from A to B along these paths in irrespective of directions. So straight away we understood what is distance now. So now let us see, as we came over here, displacement. Let us try to understand displacement. So directly I can say only one word here over this, the distance between. See, simply you can say now, as you learned about distance, you can understand displacement easily. The distance between initial and final points, initial and final points of a journey, in a particular direction. So a particular direction, if you are just going to measure the distance between initial and final points, and we call it as displacement. We call it as displacement straight away. So therefore the distance between initial and final points of a journey in a particular direction is called as displacement. So therefore in the above example, distance, I mean like directly you can say length of path 3. Okay, straight away length of path 3 is our displacement. Length of path 3 is our displacement straight away. Directly we can understand here as the person is moving in a fixed direction from A to B in the path 3. Thus path 3 is said to be, I mean like length of path 3 is said to be the displacement, where A is your initial point, as we know that initial means where we will start, and B is your final position or final point where the journey will be end. So straight away the distance shortest, or the distance between initial and final points in a particular direction is called as displacement. Or you can even simply define this displacement as by one more definition as shortest distance. Shortest distance between initial, shortest distance between initial and final points. Shortest distance between initial and final points of a journey. is also called as a displacement. So now as you are saying shortest distance, obviously it will be a straight line one only. So straight line one means it's a specified direction. So that's why I just didn't mention a word called a particular direction in this definition over here. So this is all about a distance and displacement introduction. And if you see here, what we understood is about distance. Okay, about distance, that is the length of the path between 2 points. So therefore it has magnitude. It has magnitude, but we are measuring it in irrespective of direction. So therefore it has magnitude and it doesn't have any direction. So distance has no direction. Thus the distance is called as scalar quantity. The distance is called as scalar quantity. So distance is a scalar quantity. And coming to displacement, the second quantity what we have learned here is displacement. And coming to the displacement, it has both magnitude, right? It has both magnitude as well as direction, because we just mentioned the length of the path or the distance of the path between initial and final positions in a particular direction. So it is having a fixed direction and also a magnitude. Thus it is a vector quantity. Thus it is a vector quantity. And now one more thing you can say, distance is generally denoted by small d, is generally denoted by small d, and displacement as it is a vector quantity, I would like to say it is denoted by small s, and as it is a vector quantity, bar over it. So s bar. So displacement is denoted by s bar. And one more thing you would like to remember over here is both distance and displacement are lengths only. The quantities are named after length only. So therefore units of distance and displacement are same. That is, in CGS system the distance and displacement takes a unit centimeter, and in SI system or MK system, already you are familiar, it takes a unit what? Meter. So cm represents, it is a centimeter, and m represents, it is a meter. So there are some practical units also. So sir, what are the above units you have listed over there? So you can say they are base units or fundamental units, you can say. So the practical units are there which we will be using in general. So the practical units you can say like kilometer, giving a prefix called kilo, that is nothing but 10 to the power of 3 meter. So likewise you can say even millimeter, a practical unit you can say for smaller distances. So you can say this is 10 to the power of minus 3, a prefix added called milli to the meter m. So 10 to the power of minus 3 meter. Likewise, giving the many prefixes to the unit called meter, we can have many practical units which we will be used in our daily life. Examples like, if you say size of an atom, it will be of micrometer or nanometer. Bond length is there, which is of nanometer or micrometer we are having. So many things are there which we will be having prefixes, like submultiple prefixes are there. At the same time, multiple prefixes are also there, which we have learned in earlier classes only. So by adding all those prefixes, the unit of a meter, or that is nothing but a distance or a displacement, can be converted into a practical units to be used in our day-to-day life. Hope you understood about introduction to the distance and displacement. In our next video, we will see different exceptions or properties of distance and displacement in detail. Thank you very much. Any doubts, please post in the comments so that I can have a better idea about your doubt and I can clear the doubt with a better explanation in the next video. Thank you. Have a great day, everyone.